Hello everyone. Yesterday we did this problem, maximum twin sum of a linked list. We did it by using stack. So our previous solution will have a space complexity of O of n by 2. I hope you remember the solution. And for those who haven't seen the video, the link will be in the description. So we did it by using stack, space complexity of O of n by 2. Because we're traversing the half of the linked list middle, and then we are pushing those elements into the stack, and while we are traversing to the other half, we are popping the stack and adding the slow pointers node value to it, and then we are checking the maximum. That's how we did it. In this video we are going to optimize that solution, because in interviews the interviewer might ask you to optimize this solution because they don't generally like spaced solutions. So how can I optimize this solution? So let's see how we can do this. In the previous video, what we did was we broke this linked list from here. We traversed till here, that's the middle of the linked list, and we used to keep all these elements into the stack. But now, as we are optimizing the code, we can't use a stack. We can't use a stack or any other data structure. So how can we think of it without using any space? Remember, we had to pair this 1 with 8, this 7 with 5, and 4 with 3. We had to pair with this. Alright. While we are traversing through the linked list, as we can see, the first element is pairing with the last. Okay, the second element is pairing with the second last, and so on. So we can think that we are traversing one half of the linked list through this direction, and we are traversing from the middle half, another half of the linked list. Suppose we consider this another half of a linked list, we are traversing towards the backward direction. So how about we reverse one of the linked lists? Suppose this is the first, this is the second linked list. We reverse this linked list. Let's see. So we have started traversing the linked list and we have gone to the middle of the linked list. So now we are here. So now what you have to do, you have to reverse this linked list. Alright. So for reversing a linked list, we keep a previous pointer that is assigned to null. And our slow pointer is here. And we declare another pointer, suppose nxt, that is immediate next of slow. Okay, the next pointer is here. So what we do is we remove this link that is slow is connecting to next, and we keep the link and we point slow pointer to previous. So slow is now pointing towards null because previous is null. So slow is now pointing towards null and we don't have any connection here. So there is no connection here. So next what we do is we point the previous to the slow pointer and the slow to the next pointer. After that, on the second iteration, because slow is still not is equal to null, we make the immediate next of slow as the next pointer, and similarly we remove this connection of the slow to the next pointer and point slow to previous. So slow is pointing to previous now. Okay, and what we did before, we'll do it again. We make the slow pointer as previous and the next pointer as slow. Now again, see, slow is not is equal to null, so we make the immediate next of slow, that is null, is next, and we again remove this link. This link was already not there because we removed it, and we connect the slow pointer to previous, which was 5, and then again like before we make the slow pointer as previous and the next pointer as slow. Now think, will it go to the next iteration? Of course not, because slow is null, so it will come out of the loop. and the previous, that is 8, will be our new head of the linked list. So previous is the new head. So after reversal, a first linked list looks like this. The head is at the first, and the second linked list, that the linked list that we have reversed, looks like this. The previous is at 8. We take a while loop and we make its condition that previous, it will run till previous not is equal to null. So while previous not is equal to null, we add the value of the head node and the previous node. So the first iteration, the head node value is 1 and the previous's value is 8. So it will be 9. And we'll keep a max variable that will be at first 0, and then we'll compare these two values and update it. So our max value will be 9 now, and then we'll move the head over here and previous to the next. So again we'll add this to 7 plus 5 is equal to 12, and we'll update our max. That is, now max will be 12. Again we'll move the head and previous here. Previous is still not null, so we'll move it. Now 3 plus 4. So 3 plus 4 is equal to 7. And we no longer need to update it because 12 is lesser than 7. So the 12 will be our answer, because when previous go to the next pointer, it's null. So previous will not go here because the next of previous is null. So we go out from the while loop and our answer is 12. I hope you have got the explanation and the intuition to solve this in a more optimized way. Let's now go back to our Leetcode to code this. So we are back in our Leetcode, and this was our previous unoptimized solution. So we'll keep this loop will keep, because this loop was to find the middle of the linked list. So we'll keep this loop. We don't need the stack anymore. We'll keep the max variable and we'll keep the slow and fast pointers. So we are at the middle of the linked list. So now what you have to do, you have to just add another while loop so that we can reverse our linked list. So we can reverse our linked list. So what did we take first? We took a previous pointer that was pointing, or that was assigned to the value null, and we also need a next pointer, so we'll keep it as next node. Start of next node. We'll just keep it. Okay. And what was our condition? While a slow pointer not is equal to null. So we'll run this loop till the slow pointer is not is equal to null. Okay. So what the first thing that we did was to keep the immediate next of the slow pointer to the next node. So we'll keep the immediate next of the slow pointer to next node. So next node is equal to slow of next. Then what did we do? We removed that connection that slow was pointing to the next node, and we will make slow pointer connect to previous. So slow dot next is equal to previous. And we used to swap the slow and next node and previous and slow nodes. That is, we used to make previous as the slow node. So previous will be slow and slow as the next node. Alright. And now we have reversed our linked list. Now what you have to do, you have to just sum the pairs, the twins, and we have to find the maximum. So now in this loop, what we used to do, previous will run this loop till previous is not is equal to null, because see, previous was here, right? And previous, we are using this previous till previous not was is equal to null. So till previous not is equal to null, we'll update the maxi value as previous of val, and remember head of val. And this will be of the maxi. Then what you have to do, you have to remove the previous pointers by 1 and also the head pointer by 1, and our program is done. So let's run the code. Oh sorry, this shouldn't have been there because we are no longer using the stack. Case accepted. Let's submit. So accepted solution. See, the runtime decreased from 317 to 272 because this loop, this program is using a time complexity of O of n and a space complexity of constant space complexity. So thank you. I hope you all have understood the solution, the optimized approach. If you have understood, please give a like and comment your doubts, and please subscribe to the channel so that every day I can bring awesome content for all of you, and that keeps my motivation high. So this is me, Sai Ghosh, signing off. Thank you.